Hi there, this is Ms. Page. In this lesson, we are going to finish up our learning in our Unit 3A on polynomial expressions. We are going to learn how to divide two polynomials using our long division process that we use with other types of, or all of our types of numbers, decimals, whole numbers, and it's basically the same. We have to make a few little modifications because we are working with polynomials with multiple terms, so we'll talk about that as we go through. So here are the basic steps. In that division step where you normally figure out, how many times a number goes into another number or get as close as you can, we look at it with polynomials by focusing only on the first terms of the divisor, which is what we're dividing by, that's outside the division symbol, and the first term of the dividend, which is what we're dividing into, which will be inside our long division symbol. So our divisor we find here, our dividend we find here, and then after we divide, our answer is the quotient, and then we may or may not have a remainder. So once we figure out, we use those first terms in the divisor and the dividend and divide those, then we do our multiplication step. And because our divisor is going to be a polynomial that is in general, almost always a binomial or larger, then we have to distribute when we multiply. That's what this is saying right here. That's why it says to distribute. Then the next step in our long division process is to subtract. Well, when we're working with polynomials, remember, we have to be careful with our subtraction, because subtraction in multiple terms is we have to add the opposite of all terms. So that's what we'll do first. We'll make all of the terms here opposite signs, and then we'll add the like terms together. Then, just like we do in long division of numbers, we'll bring down the next term, and then as needed, we will repeat these first four steps until we know whether or not we have a remainder, and if we do have a remainder, we will be writing that remainder as a fraction to create a polynomial structure in our final answer. All right, let's take a look at one. So one of the details that's super important to make sure that everything lines up properly is that when you're looking at your dividend, which is what we're dividing into, that would be this right here. This is our dividend. If our dividend has any missing terms after the first term, so when we are looking at our dividend, we're looking at the exponents, and we're counting our way down to our constant here, which is our -5. And if there's any power of x that's missing or a constant is missing, we're going to put a 0 in that spot to hold the place for all of those types of terms. So when we set up this problem, the 2x minus 1 is our divisor, and that is what we're going to put out here. And as I said, the first expression is our dividend. So I would write this here. So I have a 6x cubed, and then I have a plus x squared. And if you want to, you can put a 1 there if that's helpful. Notice then I have no x term, which would normally be the next type of term. So what I'm going to do is put a plus 0x to hold the place for all of the x terms that I will get later on. And then I have my constant term at the end of -5. So when I go to do the first step, I am going to focus on 2x, the first term in the divisor, and the 6x cubed, the first term in the dividend. Now my job is to figure out what times 2x will exactly equal 6x cubed. So using my multiplication skills, I knew 2 times 3 is 6, and I know that x times x squared would be x cubed. So that makes my first term here in my quotient a 3x squared. So now our next step is to multiply. Well, we are taking the 3x squared and we're multiplying it times our binomial divisor of 2x minus 1. So we have to distribute that. And I highly encourage you to write that over here, because this, the first one we're pretty good at keeping track of, but a lot of people make mistakes with that second part of the distributing when they don't write it side by side like we're used to seeing. So that the product there, we're going to write underneath our like terms, so we get a 6x cubed, and that's good because these first two should match each other. And then we get a minus 3x squared, which would go underneath our x squared. Now remember, your next step is to subtract. So before you subtract, before you combine any like terms, you want to make sure that you change the signs of the 6x cubed and the negative 3x squared before combining. So our subtraction becomes addition. This 6 becomes a negative, and this negative 3 becomes a positive. So now we have 6x cubed plus negative 6x cubed, which is 0. And that first one should always be 0. Sometimes the other ones end up being 0 also, but that first one has to be 0 so that we start decreasing the power that we're working with to get to the end of the problem. So now I have 1 plus 3. That gives me 4 or positive 4x squared, and I bring down my next term of 0x, and now I'm going to repeat the process. So now I figure out, going back to my first term of 2x over here in the divisor, now I focus on this new first term here of 4x squared. And I have to figure out, well, what times 2x will exactly equal 4x squared. 2 times 2 is 4, and that's going to be positive, so I have a plus 2. And then I have what times x equals x squared would be x. So now we have to take our positive 2x squared in our quotient there and distribute it to our divisor of 2x minus 1, and 4x squared minus 2x gets written here. So now we're to that subtraction step. So again, before combining, you got to remember, change those signs. So subtraction becomes addition. Positive 4 becomes negative, negative 2 becomes positive. And so now we have a 0, and 0 plus 2x would be 2x, and we bring down minus 5. This is going to be the last time through. A couple of ways I know that. One is that I just brought down the last term, so that's always going to be the last time through. But also we're going to end up with something after this with a degree or exponent that's smaller than the x to the first power in the divisor. Now we need to know what times our 2x in our divisor will exactly equal this 2x. So that would be a 1, a positive 1, so that gives us a plus 1. And now we're technically distributing that positive 1 to 2x minus 1, which of course is itself 2x minus 1. Be careful here. A lot of people make mistakes because they forget at this last step that you still have to subtract. And so that means that you have to first change the signs before adding and combining like terms. So subtraction becomes addition, positive 2 becomes negative, negative 1 becomes positive, and now I have 2x and negative 2x, which is 0, like it's supposed to be. Those first ones are always 0, and negative 5 plus 1 is negative 4. So now I should realize that this negative 4 is my remainder, because the degree or power of x here, since there is no x, it's considered to have a degree or power of x to the 0 power, which is smaller than my divisor of x to the first power. That's another way of knowing this is your remainder. So now I'm going to come up here to my quotient and write a plus, and I'm going to remember we're going to write our remainder as a fraction. When we write remainders as fractions, we take our remainder and we write it over our divisor. So this becomes plus negative 4 over the divisor of 2x minus 1. And this then is our answer to this division problem. All right. Here is a practice problem for you to try. I encourage you to pause the video here and then come back when you're ready to check your answer. Let's take a look at the answer now to this practice problem. So over here is hopefully what you got. If you did not get, here's your quotient, the trinomial. And then your remainder is negative 3 over the divisor, what we were dividing by, of x minus 2. And then take a look at the work if yours doesn't match and try to find your mistake. All right, let's take a look at this example. So in the previous problems, our divisor was a binomial. Here, our divisor, this is why it's super important actually to understand the structure of this type of division problem and realize that this is taking its first polynomial and dividing it by the second, which means that whatever is after the division symbol is always the divisor, which is always then going to go on the outside of that long division symbol. And whatever is first is always the dividend, which is what we are dividing into. And that's what goes inside. So here we have a 15x cubed. Notice we have no x squared term this time. So I put plus 0x squared. Then I do have an x, so I put my plus 8x, and then my minus 12, my constant term at the end. So again, that process that we have to learn. We focus on our first term in the divisor, which is our 3x squared, and the first term in our dividend of 15x cubed, and we have to figure out what exactly times this 3x squared will equal exactly 15x cubed. So 3 times 5 is 15, and x squared times x would be x cubed. So we actually get a 5x. So I'm going to put it here over the x term. Line everything up with like terms. So now we're to the multiply step. So we're going to take the 5x in our quotient and distribute it to our divisor, which is this trinomial. And those 3 terms we're going to line up with the like terms in the dividend. So we're going to get our 15x cubed, which matches like it should. These two should be exactly the same right now, because when we subtract them, they will become 0. And then we get plus 30x squared, and then we get plus 5x. So now we're to that subtraction step. So again, before we combine any like terms, we want to change all the signs. So subtraction becomes addition, positive 15 becomes negative, positive 30 becomes negative, positive 5 becomes negative. Our 15 and negative 15 add up to 0. Our 0 plus negative 30 gives us a negative 30x squared. Our positive 8 plus negative 5 gives us a positive 3x. And then we bring down the next term of minus 12. Now, hopefully, we start to realize this is going to be our last time through the process because we brought down our last term. So we should expect to get our remainder after this next go around. So now we focus on our first term in our divisor again of 3x squared and our new first term here of negative 30x squared. We have to figure out what times 3x squared exactly equals negative 30x squared, which means that we need to realize, well, 3 times negative 10 is negative 30, and we already have the x squared. So this would be a minus 10. That's one of the biggest spots where people tend to make their mistakes, is that they, even when this is a negative number here, they skip making them the same. You have to make them the same first because the next step has to be subtraction. And the only way that part turns out to be 0 is if we subtract something from itself. So now we're going to take that negative 10 and distribute it to our divisor. So we get negative 30x squared. They match like they should. Then we get minus 60x minus 10. Now we're going to do that subtraction. So again, before I combine anything, I have to apply the subtraction procedure, which is to add the opposite sign of the term. So I change my subtraction to addition. My negative 30 becomes positive. My negative 60 becomes positive. My negative 10 becomes positive. So now I have negative 30 plus positive 30, which is 0, like it should be. I have 3 plus positive 60, which is positive 63x. And I have negative 12 plus positive 10, which is a negative 2. This right here I have to realize is my remainder. 2 ways. Remember, we've already brought down the last term, so there's nothing else to bring down and go again. Also, notice the exponent on this x is a 1. And that's smaller than the highest exponent in your divisor here of 2. So the moment that this exponent on this part here gets smaller than the degree of your divisor, you're at your remainder. So now we're going to bring this up here and write it as a ratio or a fraction. So we write our plus, and then we write our fraction. So our remainder goes in the top, 63x minus 2. And it's over our divisor of 3x squared plus 6x plus 1, like so. All right, moving on. Here's a practice problem that's similar for you to try. I encourage you to pause the video, try this problem, and come back when you're ready to check. All right, let's go ahead and check this. So here is hopefully the result that you got, where the 4x minus 10 is the quotient, and the remainder is 29x plus 15. If you didn't, please take a look at the work and do your best to find your error spot. Some common error spots to look for, or spots to look for those errors would be when you do the subtraction here, or maybe here. and that you made this negative so that it would match the negative, and also the other spot that when you combine, when you do the subtraction, like I know this is addition, this becomes negative, making sure that sign is correct. Those are some big spots for errors. All right, now in addition to just basic division, we're going to learn a way that we can use long division to help us with understanding polynomials a little bit better. So we have a couple of math theorems here. It just means things that about math that we know are proven to be true, and they're called the remainder and the factor theorems. So together, what these two theorems really will tell us is that if we divide two polynomials and the remainder that we get is 0, then we know that both what we were dividing by, which is our divisor, and our answer, our quotient, are factors of the dividend, which is what we were dividing into. So here is a number example of that type of thing. So let's say that we had 3, we were dividing it into 12. So 3, we know 3 times 4 is 12. So when we multiply and subtract, we get a remainder of 0. This remainder of 0 in polynomials is going to tell us, just like it does in numbers, that 3 times 4 is equal to 12, which means that 3 and 4 are both factors of 12. All right, so let's look at a polynomial problem. So we're supposed to figure out whether the binomial, which here is shown as x plus 3, is or is not a factor of this polynomial function here called p of x. So to figure that out, we have to understand that the binomial we're trying to figure out whether it's a factor or not, this would be our divisor, what we're going to divide by. And our polynomial function expression will be our dividend, what we divide into. That will always be the case. So that means I have x plus 3, and I'm going to divide it into this dividend. Notice there are no missing terms in this dividend. It goes x cubed, x squared, x to the first, and constant. That means I don't need any of those 0 terms this time. So I'm just going to write what I have. No zeros necessary. And then I begin my division process. So what times x equals x cubed would be x squared. I put it here. Then I'm going to distribute the x squared to the x plus 3. And I get x cubed plus 3x squared. Then remember we subtract, which means before we combine, we change the signs. So here, the subtraction becomes addition. This is a 1, so that becomes a negative 1, and this becomes a negative 3. So 1x cubed plus negative 1x cubed would be 0, like it's supposed to be in that first spot. And here we get 3 plus negative 3, which is also 0. This sometimes happens. So what do we do now? Well, because our divisor is 2 terms, in the next division, we actually need 2 terms, and 0 isn't going to be helpful for that when we divide into, so we bring both of these down. It's a little different there, so don't lose that sign there, minus for a negative, so we have negative 4x minus 12. We just sort of ignore that part. And then we divide again, so what times our x here in our divisor equals exactly this negative 4x, and that would be a negative 4. And then we distribute the negative 4 to the x plus 3. And that gives us negative 4x minus 12. And then again, we are going to subtract. We are going to subtract that quantity. So we change our signs. So it becomes addition, negative 4 becomes positive, negative 12 becomes positive, and negative 4 plus 4 is 0 like it's supposed to be, and here again, negative 12 plus 12 is 0. Now this 0, since we've already brought down all of our terms, that is our remainder. And our remainder of 0, according to our theorems, now tells us that, okay, we got a remainder of 0. That means that x plus 3 is a factor of p of x. So now you have a conclusion to write, because this is more of an application of the skill of division. So we would say something like, the binomial of x plus 3 is a factor of p of x. Then I'm going to do my reasoning. Because the remainder is 0. And you can write the number 0 or you can spell it out. Either would be fine here. Something to keep in mind, if you'd gotten in your remainder spot, if we had gotten any other number than 0, then our conclusion would have been that x plus 3 is not a factor. Those are the two options. It either is a factor if we get a remainder of 0, or it is not a factor if we get something else. All right, so here's a practice problem. Please pause your video and try this problem. All right, let's take a look at the answer. So it doesn't show all the division work, but in this one you should have also gotten a remainder of 0. So this one's worded a little bit differently. It starts with the explanation first. Since the remainder is 0, we can conclude x plus 2 is a factor of p of x. All right, that finishes this lesson. I hope you have a wonderful day.